All right. I'm really excited to be here. This is my first Rust conference in person. At least a couple of other ones that I've done before were online. So it's really nice to see a lot of the faces that you typically see online and a lot of the people that contribute to the project. So a little bit about me. I'm currently the head of research at a company called Connected Motion in Amman, Jordan. And we are a company specialized in mobility services. I have around 20 years of experience both in academia and industry, where I come from a background in automotive embedded electronics mostly. And I started with Rust 3 years ago. And it was a total coincidence in the sense that I saw a job posting, and it has the usual skills of C and C++ and embedded. But then I saw the word Rust, and I had no clue what it was. So I started looking further into it, and the more I got into the language, it was like this is what we were missing in the industry. And I figured that, well, from an educational perspective, my own reflection was that things were a little bit tough to learn, at least in those days. And I figured maybe I'll take an educational angle to things and start contributing with educational material. So I started with blog posting in the beginning. Some of you might have seen those with STM32s. And then later, when Espressif jumped on board, I started doing Espressif blogs. I ended up publishing the Simplified Embedded Rust book or series, which is a sort of a series that keeps on getting updated with all the crates that come along from Espressif. But then I also started the embedded Rustacean newsletter. Some of you might be subscribed to it as well. So the idea was to keep everybody within the embedded Rust community informed about what's going on as well. So before getting into the presentation, I want to offer some perspective on something that I really find amusing. And if we look at a language like C, that has been around since the 70s. And, well, we're talking about more than 50 years, with deep roots in the industry. And then compare it to Rust, which, at least when we're talking about the language itself, origins in 2015. But if you want to talk about the milestone of embedded, it's probably when the embedded work group came together. That was around 2018. So you can say that we've been around for 8 years or so, and that a conversation is actually happening about potentially replacing a language that has been there for 50 years is something that I find extremely astonishing. So along those 8 years, if we expand, there's a lot of things that happened, and this is obviously not everything, but there's some crates that have reached stability, of which probably the largest new announcement was the ESP HAL reaching 1.0. But I figured that with this presentation, I'll probably take a different angle to things. Rather than just talking about the ecosystem where it is right now, maybe we can look at where it can potentially go. Because with that quick growth, maybe there's opportunities that can help it even grow quicker. So if you're a beginner or new to Rust, or considering even embedded Rust, I think that the question shouldn't just be whether you should learn Rust, but also how or where you can contribute to Rust. Because if we have increased adoption, then we can build an even better ecosystem and vice versa. As we have better ecosystems, we will have increased adoption. So what did I do? I looked at the surveys from last year relative to both embedded and Rust, and tried to derive some insights, which I'm including into this presentation. So as we go, I'm going to be referencing these a lot, in addition to other material that I've came across, and even social media posts relative to certain aspects of the ecosystem. So before digging into that, I'd like to provide some context. Some of you might be familiar with this, some not, but just to make sure that everything is clear going forward. So typically with embedded we would have some sort of microcontroller platform or hardware, something like an STM32, ESP32, what have you. And then within that, we would have a processor and some peripherals that are around it. And essentially, to be able to layer any software on top of that, at least the first step is that we need a compiler that can support the low-level architecture, that can generate binaries that are compatible with that. And once we have that, essentially one of the crates that you would see that are common is a microarchitecture crate that gives you access or enables you to drive the processor inside the microcontroller. And then we have peripheral access crates that allow us access at a register level to peripherals. So typically at this level, things are not too ergonomic, and you have to keep referencing data sheets and looking into bits and bytes and where things are located. So there is a hardware abstraction layer typically that is built on these that gives you a more ergonomic API to access this lower level hardware. And essentially, sometimes this might be enough for bare metal development where you can write your application right on top of this HAL and start coding whatever you want to do with your controller. Now, there are some optional layers that sometimes are included, like a board support crate. So you have your platform or controller on a development board. There are some board support crates that allow you to control different functions on the board. And then sometimes you can include a framework or an RTOS that also would give you some sort of like OS-like functionality. And finally, you'd have your application. And typically within this application, when I say hardware agnostic, it's in reference to the utility crates. So something like a graphics crate or a math crate or what have you. Now, another interesting thing is that, well, apart from this structure that I was just talking about, or the stack, there is something that is trending that you see coming up more often nowadays, which is a stack that looks like this. And I'm referring to it as a Rust on top stack. So the idea behind this is that I think it was referenced in one of the earlier talks as well. If you have an existing code base, C, C++, you just include or create a layer of Rust bindings on top of it, like a wrapper, and then write your Rust application on top of that. And there is a very good example of this, which is the standard framework with the ESP IDF framework that does something close to that. OK, so what are the 5 pillars? So the first pillar is development tools. So these are pillars that I've came up with based on the trends that I've been looking at. And the second one is debug and test, then the crate ecosystem, and frameworks and RTOS, and finally, education and resources. So starting with development tools. So the idea here with development tools typically is that we'd like to streamline the workflow, make things easier for developers. So in terms of current state, one of the good things that developers have been reporting or mentioning in surveys, that it's fairly easy to adopt the tool chain that exists. And this is for embedded developers that are using Rust. And then when it comes to tool base, there is a solid tool base, which, interesting enough, from the surveys, what we see is that the most popular tools, at least the top 2, are not necessarily embedded specific tools, but tools that were created for the Rust language, like Cargo and Rust Analyzer. And then, whoops. Finally, something that is really interesting is that within the industry, embedded industry, safety is prioritized in a lot of projects. And interesting enough, again, we have already safety certified compilers in which there's, for example, the Ferrocene project for those that are familiar with it. And I think there's at least 2 other efforts for compilers that are safety certified to be able to certify your product for a safety application. So what opportunities are there? One of them is interoperability. So by this, I mean, so some of the feedback that you see sometimes by developers is that, well, right now we're using a certain set of tools for our embedded environment, and we're considering to switch to Rust, but we're worried that these tools might not work anymore. And in this particular case, it was in reference to a what's it called, a profiling tool. So that is one thing. Now, it may or may not work, but probably part of the issue is that, well, for whoever would have checked something like that or tried it, there isn't information that is being propagated within the community that, yes, these tools work. So this is a potential opportunity there. And another one, and we have one of the team members from Pictours there. This is a quote when we first started talking to each other, is that a significant pushback within certain industries or niche applications like automotive control is something like model-based. And they say that, well, we're missing model-based tools that do Rust. So especially for those that are dealing with Simulink and tools like that. Another opportunity is Edge AI. And this is something that I find really interesting. With AI being sprinkled on every industry nowadays, this is a survey paper from last year surveying the space of TinyML within, obviously, the context of embedded. And there is no mention of Rust whatsoever in that. I know probably of a couple of efforts or crates that have some sort of embedded support, but again, with all the buzz around AI, you probably don't see a lot of activity within that space in embedded Rust. Finally is compiler support. And this is something really interesting, because it turns out that within the embedded industry, there's a lot of groups that are using different niche architectures. So if you recall, when I referenced that stack earlier, we said that you need that compiler that allows you to compile code for that underlying architecture. And it seems like there's a lot of these niche architectures that are not supported by the current compiler. And there is an effort ongoing right now creating a Rust front end for the GCC compiler, which has hopes of unlocking a lot of other architectures. And interesting enough, a few days ago, or a couple of days ago, I was in Embedded World, and the team that's working on that, there were some of the members. And in terms of timeline, they said that they expect something to come up next year, around April, they said. So hopefully, there will be something there. So moving on to debug and test. So with debug and test, hope or the idea or the goal that we want to achieve is to speed up and automate and hopefully lower the risk of failure. A very interesting statistic from one of the surveys is that there up to 50% of embedded developers actually think that their cybersecurity products are not adequately tested when shipped under time constraints. So in the same time, developers report that one of their main motivations to adopt Rust is safety and reliability. So in this context, the language itself would help. Not that you be hopefully shipping your code, or not that you be shipping your code without testing, but at least it seems to be giving some level of comfort. Okay, tool base as well. So there are some tools out there, and probably the most popular one being ProbeRS. It supports flashing, debugging, and there's also embedded tests, which you can do hardware in the loop as well. So there is a good tool base when it comes to debug and test. And finally, we have increasing vendor support, of which the last one, Rust and Soft, I added only yesterday because the announcement came 3 days ago. And it was by chance when I passed by their booth at Embedded World, they told me that we just announced a static analysis tool. So these are some of the well-known players, if you will, within the embedded industry, like Seger and Lauterbach. And then, well, Trust and Soft is the newcomer to that. So maybe even some of them, the support is, there is some form of support, probably not for a lot of features, but at least it's there. Okay, opportunities. So one of them is debugging interoperable code. So this is highlighted in one of the the survey papers, that it is one of the second major issue in debugging. And interoperable code, like one of the talks that was mentioning FFI earlier, So you have a mix of code bases, and we said that, well, this is also trending. It seems like it's not easy to debug interoperable code. And one of the other aspects is also async or asynchronous code. So there is more opportunity or area there to enhance. Another is static analysis tool. So also, well, this is from the paper from 2024. So the trust in soft tool that we just mentioned wasn't out there yet. But what was really interesting in terms of these static analysis tools is that what this paper has done, they grabbed some of the popular ones and tested them on embedded code bases. And noticed that probably the one thing in common that all of them don't do well is also async. Finally, this is something that is more, I would say, embedded rather than specific to Rust, which is remote health monitoring. So this is probably an aspect of DevOps within the context of embedded, and it's about monitoring your hardware while it's in the field so that it allows you to be able to fix things faster and focus on new features rather than getting stuck in the past. So third pillar is the crate ecosystem. So with the crate ecosystem, this is actually a screenshot from lib.rs. Okay. So if you try to highlight the embedded crates, we have a very small chunk out of a large space, which is 3,660 crates. Now, one of the papers did an even deeper study in the sense that this is typically associated with the keywords that developers put into their crates. So if they didn't put the embedded keyword, then it wouldn't appear here. And they found out that at least in terms of compatible crates, there's more like 6.4K crates that are compatible with embedded, of which 74% of those are utility crates. And then in terms of coverage, the community has done well, obviously covering the most popular platforms and architectures in terms of crates. But here, in terms of opportunity, we have sort of the same niche, if you will call it, struggle appearing. So this is both relative to not just microcontroller hardware, but also device drivers. So it was highlighted in one of those surveys as the #1 reason for discontinuing the use of Rust. Okay? So obviously, this is a significant problem that teams are facing. And well, in the most recent release for Espressif, for the 1.0, there was a blog post written by Scott Maben about the journey that they went through. And well, for them, the journey also started from the compiler where they introduced support for the Extensa architecture. And as you can see, that was nearly 6 years to be able to get from that point until reaching V1.0. So one project I like to highlight is one created by Dion Doctor, which is one of the people within the embedded Rust community, that he created a toolkit that allows you to accelerate the creation of device drivers. And this would be something, obviously, that helps keeping up at least with trending drivers, whether it's new sensors that come up or what have you. So this is an interesting aspect, which is the standard crate interoperability. So in one of the papers, they highlighted that, well, there is probably opportunity for creating a tool that can automatically convert a standard crate to a core crate or make it compatible with core. That way we can take advantage of that whole space that we're not tackling or using currently. Frameworks and RTOSs. So within probably Rust, when we're looking at frameworks and RTOSs that are pure Rust, there's probably not as many choices when you look at other languages like C, but there are quite some innovative choices, one of them being Embassy, supporting asynchronous operation. So also there is a nice website that if you want to find out what's going on with all of the RTOSs that are being in Rust, it's arewertosyet.com. that gives you an update of all of things going on, or what is the state of each one of those projects. Now, an interesting thing that I saw or noticed in this is the State of Rust survey done by, I think, the Rust Foundation last year. When individuals were asked about their own choices for developing embedded, their preference was bare metal in terms of embedded. But when they were asked about the organizational choices, it was actually OS-based frameworks. So it's quite different what the personal choices were versus the organizational ones. And within organizations from the Eclipse Foundation survey, it turns out that Linux and free RTOS are the most popular choices right now within the industry. And essentially, with any choice, developers, what they're looking for is something that is high performance and also easy to integrate. OK, in terms of opportunity, there's FFI automation. Somebody from Safety World might think this is freedom from interference, but it's actually, well, the foreign function interface in Rust. And the idea behind this, and I think we've seen that in the earlier talk, is that, well, there might be more opportunities to automate this importing existing code bases and adding sort of those bindings that you can use in your Rust code base. Because there is some part to it that is manual, even with tools existing like BindGen. And another is RTOS certification. This one is probably not as simple, but this has to do with, well, safety certification, to be more specific. So there was a project that was started by the European Space Agency to create a safety-critical RTOS for space. And this is a comment from one of the engineers on Hacker News, that given the resources that they had and the time, it wasn't enough to be able to certify that RTOS. Because for anybody probably that have went through that process, they know that there's a lot of collateral that you have to generate, a lot of process that you have to adhere to. So it's not something that is straightforward. Next is education and resources, and this is my favorite part, because this is the part where I'm in. So the idea is to lower the barrier of entry, to grow the community. Rust is still perceived as difficult, and probably this is the stereotype for Rust. And, well, in the State of Rust survey, 30% have mentioned that, well, it's still too difficult to learn when they were asked, why aren't you using Rust? And the alarming part that I noticed within the State of Rust survey is that, why did you stop using Rust? That went up from 23% to 27% between 2023 and 24 because they thought it was too difficult to learn. So on the other end, when you look at those surveys, there's probably not much that you see in the context of embedded. So the State of Rust survey also asks about what are the most popular material that users prefer. And documentation, books, and source code were the top. But this is more towards Rust rather than embedded. So there's probably more to look into on what resources many use for embedded. Now, the other ones that are mentioned as well, there's probably some aspect that, well, is it that these are not as popular because there isn't many resources of that type? Or is it because users actually prefer the ones that are on top right now? OK, so a key part here is that we still need to change perception. OK. Rust might be hard in some aspects, but also the material can help make it easier. So there is a worry within the Rust community, apparently, that the language might get too complex. So this doesn't help either. So there is some work or opportunity there within the Rust community, or even the people that are considering Rust, to soften the blow, if you will, that, well, it's not really that bad, as long as, you put in some effort to it. Now, this is something that I have seen that is common, and I've experienced it myself, which is documentation examples. I've noticed even in my early days in Rust, looking at documentation, actually figuring out how to read documentation was one thing. And once I figured that out, there's a lot of APIs that you don't necessarily know what it does. You just have to experiment to figure out, or even look at the source code and try to reverse engineer what's going on. So there's a lot on the developer end that when they create these resources to make sure that there's a better documentation or explanation to what is being done. Now, this is from my aspect. So I wrote a blog post about this last year. And these are some of the main things that I think from an education perspective could really help in advancing Rust embedded. So minimizing reverse engineering, this is sort of goes in hand with the documentation example. So maybe one of the main examples that I had there is at the time that, well, there is a certain how that the developers would tell you there's a bunch of examples, go and look at them. If you're a beginner and you have no context, you have to reverse engineer to understand what actually is going on. And sometimes, in some cases or instances, I would run into something that a certain sensor is being used, and it's one that I've never dealt with, and I have to figure out and look up the datasheet to see what that sensor is to be able to understand what this example is doing. So for a beginner, obviously, this is something that would be really intimidating. Another part is virtual learning tools. So there is one website called Walkly. I don't know how many of you have used that, but it is one that I tried to incorporate in the book as much as possible. This is my personal experience with my own students when teaching embedded, and this was based on C, not even Rust, is that they spend more time on setting up tool chains and wiring in the beginning before actually coding. And they're still beginners to the space, so they run into so many issues that it becomes sort of a space that they don't like so much because they ran into problems right from the start. So there was a whole talk that I did about this in Rust DevCon last year, and it was more about shifting or pushing these more towards the end and leveraging more virtual learning tools in the beginning so that beginners or students don't have to deal with that. And then finally, there's all of this other material that, well, there should be, I think, more of it to educate the community on how to do things to address some of the areas that we were talking about earlier, like doing FFI and generating device drivers, or what are the best practices, if you will. So what are the takeaways? So obviously, quality contributions are important, and it is key to speeding up the growth of the ecosystem even further. And we noticed that there's an increasing prevalence of FFI, so this is a space that probably more should look into. And then niche device support was something that, again, we've seen almost across several pillars. Education is a growth catalyst, but in my opinion, I feel that it's the one that is the slowest growing within the ecosystem. And maybe this is something that I actually added this morning after having some conversations with some of the attendants outside, is that maybe it would be worth starting some sort of effort by the community to aggregate information from the industry to derive better insights. Because in the end, surveys, the way I see them, they're sort of one way, and they could be biased. And sometimes you can't really understand why data is in a certain way if you don't follow up with another question. That's all I had. So if you want to subscribe to the embedded Rustacean, this is the link, which is the newsletter that I was mentioning. And this is the email if anybody wants to reach out for any questions. So thank you.